After you finish the table, you guys can see the pattern, but we're having a hard time describing it. Because how does this pattern relate to what's going on with the 9? You know, like you see, like first we start with 9 and we got these 4 decimals. Then we have 90 and we got these 4 decimals, but now we have this 1 right here. We got 900, we got these 4 decimals, and now we got this 2 right here. Like, how come it's increasing by 1 every single time? Well, it's related to the x values, the 9, the 90, and the 900. How can I get 90 from 9?
10 times 9.
You multiply it by 10. You multiply the 9 by 10, right? Yeah. And then how can I get 100 or 900 with 9?
100 times 9.
So you would go 10 times 10, right? You multiply it by 10 twice. So to get the 90, we multiply it by 10 once. To get to 900, we multiply it by 10 twice. Do you guys see that? You see how we got the 2? Because we multiplied the 9 by 10 twice. Oh. So I know we spread this lesson out, but we learned something about taking logs of 10. You guys remember that? Like if we took a log, don't write this. If we took a log of 10 to the 6, we know what that is. Because we know that the base is 10. If the base is 10, then what this log is saying what power of 10 would give you 10 to the 6th power? And this answer is just too obvious.
6.
It's a 6. So earlier we talked about how you get 6. I think it was formally written for you guys like this. Log of 10 to the k would equal a k. That's on page, I think, 108 or 107. I can't remember. I think it's on 108, on the bottom of 108. So using that, knowing that, let's rewrite what this is saying. So I'm going to rewrite this right here. Now this is saying, what is log of 900? That's what you did in your calculator. You said, what is log of 900? Well, here it is. Let's write it like this. What is log of 900? Can you guys write that down? And then how can we rewrite 900 with the 10? 9 times 10. Let's write log of 9 times 10 to the 2nd power, right? Because it has 2 10s. So that this stuff is inside the log. You don't have to put the parentheses there, but it does help. Now, there was something else that we learned. Do you guys remember what we learned about when we have multiplication inside of a log? This is on your other page too. If you turn just one page back, you see the top of the left page. It tells you what you can do when there's multiplication. Tell your neighbors. So you can see that we can write this as log of 9 plus log of 10 to the 2nd power. Did you guys, is that how you wrote it?
Yeah.
Okay. Now, instead of writing log of 9, I can write what log of 9 equals right here. We have, well actually this is a rounded answer, 0.9542. And then, do you guys know what log of 10 to the 2nd power is? Come on, come on. We just talked about it. What's log of 10 to the 2nd power? It's 2. Right? It's 2?
Yeah.
Okay. So then we get our answer. Now 2 has a decimal right here, so this is actually really simple to add. That's what you get. You guys see that? Okay, let me take you down to the formula box, which is right here. Now, I think this formula box was actually written a little confusingly. Shh. Yeah, let me show you. They skipped a step here. This log has multiplication inside of it, so we can actually write this as log 10 to the k times log of x. What is log of 10 to the k?
K.
It's just k. And then we just put an x in there. So this can be written like this, which can then be written like this. So skipping this shortcut, I feel like when you're really new at this, might be confusing.
Yeah.
So I don't like skipping that middle part. You guys see it? Understand it? You guys didn't see my mistake?
There's a mistake.
I put times right there. What should that be? A plus. Yes. Okay. That's addition right there. Okay. So let's look at the other page. All right. So here's the other table you guys had to fill out. Now this table right here is exactly the same as the one you just did, but now it didn't follow the same exact pattern. But then when you went over here, it kind of did follow that pattern. And now the numbers are negative. What the heck? Yeah, so we're going to do pretty much the same thing. So let's look at this guy. We'll look at 0.09. So we found log of 0.09 using a calculator. Can you guys write 0.09 with a 10? Good job. It's 9 times 10 to the negative 2, right? Because we'd have to move it 2 times.
Yeah.
Okay, so what do we do with multiplication inside of a log? We write the log twice and we add them. All right, guys, this is the hard part. Well, actually, we're almost there at the hard part. So do we know what log of 9 is?
9.
It's 0.9542. Whenever you guys have problems like this, the table will be given to you. You just use the numbers to, like the way I'm using them right now. You guys won't have to create the tables. And then we say plus, and then what is log of 10 to the negative 2? It's negative 2. So how do we add this positive number to this negative number? I know, we got to take you back. Way back. Back in the time. All right. Hey, yeah, you're right. We subtract. So I'm going to take that 2, and since the decimal is right after it, I'm going to add 4 zeros, so then I could take away 9542. Okay, now, just pay close attention, because some of you guys forgot subtracting decimals. I can't go 0 minus 2 in this way of subtracting. Now, there's many different ways of subtracting. This is the way I think most of you guys learned. We take away from this 2. We borrow from this 2. We make this a 10. That becomes a 9. Make this a 10. It becomes a 9. Make this a 10. It becomes a 9. That make that a 10. So what is 10 minus 2? 8. 9 minus 4 is 5. 9 minus 5 is 4. 0 points. And then is our answer positive or negative?
Negative. Negative because the 2 is bigger.
Yeah, negative because 2 is farther away. Negative 2 is farther away from 0 than 0.9542, and so we know that the answer is going to stay negative.